If you are ingesting lots of data, depending on your data model, you might just simply always assume you're going to insert data. But if the data happens to be there, you want to update it. So we often call that an upsert. And in Postgres, that is done as a insert on conflict. So when that data actually exists, there's a conflict in what I'm trying to insert, do something, in this case, do an update. And so that was not possible up until recently in TimeScale DB on what we call hypertable. So our time series partition table just wasn't. We were not taking advantage of some of the fixes that had happened in previous versions of Postgres to pass through that update based on a constraint name. So I think that's why it's come up more often in a platform like Hasura is folks had their database because of their ORM. Every table, including the hypertable, had a primary key that was both time and usually a big int or something like that. And so these upserts would happen, and every so often they would actually do the update. But now we would have this problem with the named constraint. So that's all fixed. It now works. So it's been a longer standing issue, but one that we're happy to finally push through, along with a lot of updates over the last 6 months or so.
Well, hello and welcome to another Data and API show. It is great to have you all back here today. We are continuing along with databases, all things databases. We've had so many different kinds on this show so far. And today we actually have TimeScale, which is one of the darlings of the Postgres flavor hosted option DBs out there. And to give us sort of the rundown and actually a sneak peek on some of the updated patches at TimeScale, we have Ryan Boots. Ryan, welcome to the
Hello.
show.
How you doing, Jesse? Good to see you.
I'm doing good. Now, we actually postponed this show because you told me last time when I contacted you that there was going to be some new releases happening, and they released and they're out. And so here we are. We're going to be talking
It's
about the
true.
cool stuff. Why don't you give us a quick
For sure.
rundown of who you are, what you do at
Yeah.
TimeScale, and we'll get going.
Sounds great. My name is Ryan Booz. I am part of the developer advocacy team here at TimeScale. Been here for just over 2 years. So TimeScale is, as a company, a little bit older than say 5 years or so. The extension itself has been around for going on 6 plus 7 years or so. The team has been working through this for a long time, really believing in the story that is Postgres, the rock solid nature of the database and what we're able to do with it, and the extensibility of it. And so that's what TimeScale was built out of. So I help with a growing developer advocacy staff, trying to help people understand how we can use Postgres with all the exciting features that are in the extension called TimeScale DB, and then our cloud-based service to really use all the Power SQL on massive time series data. And so up until say, you've been in this game for a long time. Obviously, Hasura has been around for a long time. In time series data, if you go back 15 years, I've been doing database stuff for the better part of 25 years. And honestly, until I found TimeScale DB, if you'd have asked me, hey, I'm gonna keep billions of rows of time series data in my regular relational SQL database, keeping all the indexes and what have you, and not have to worry about managing partitioning on my own and whether or not the query engine can handle it, I would have said, no, thanks. I'll never go there. And in TimeScale, the engineers have found a way to really do this well, utilizing partitioning in Postgres and a lot of the cool stuff we can do in the query engine to make time series queries efficient, a lot of features that I always wanted as a developer. So when I'm using time series data, we need to aggregate stuff up to minutes and hours and days and months. And that just always was a real pain. I had to come up with a way to do that, and we give you those tools in TimeScale. So
And then beyond just the extension, then so you also like obviously any service that is doing that kind of real-time partitioning and that kind of computational power takes up resources. And it's not just about is it possible, but it's also about what's the database doing to the hardware under the hood. And so that's where TimeScale also has a great, it's got that open SaaS model, right? So you have the ability, you could run it yourself, or now you also have the ability to kind of click deploy a TimeScale DB too, right?
Absolutely. Yeah. So TimeScale, the extension is what a lot of people call, we have two licenses. So one is Apache 2. So there are features of Postgres of TimeScale DB, the extension, that are free, completely open source to everybody to do anything they want. The extension itself then has a TimeScale license, which for 99 point X percent of the world is completely free as well. So it's a license that simply says, hey, we are providing a hosted solution, and so if you don't want to manage a timescale database on yourself, we would love to do that for you. So you won't be able to use, you can use timescale in a number of hosted environments. They do provide the Apache 2 feature set. They're not allowed to provide, for instance, say a couple of the advanced features, and that you can come to us to do. We have a world class team, engineers that have been involved in the Postgres project for literally decades. We're talking 25 years of Postgres, and some of them have been involved for certainly more than 10 years. And then we have folks on the team that are running the environment that have just had their hands in Postgres, things like the Patroni module that does a lot of your high availability in your application. We have some of those engineers that have just been deep in the mechanics of Postgres for a long time. So we're really aiming to build a world class hosting environment for your time series data.
Sounds awesome. So let's talk about the deploy, the patch
Yeah.
that got released here. So there was an issue with a update patch, right? So why don't you give us kind of the history about what was the issue? Because I remember even
Yeah.
old article we had something talking about the workaround.
Yeah, so maybe a really quick background of Postgres. So again, timescale DB is built on Postgres. We were using it as an extension. So you go back to Postgres 9 point something. My history brain is not in gear at the moment. When full extensibility really became possible, and so that's why a lot of really awesome extensions like Timescale and others are able to do what we do. So we can take full advantage of what Postgres does, and then there are many hooks. Sometimes it's at the data layer, sometimes it's at the query layer that we can take advantage of those hooks and do unique things that we need to for the setup of the database. And so one of those things is partitioning, and we do one of the two flavors of partitioning in Postgres. So some of those developments, we don't modify any Postgres code whatsoever. We are simply using the hooks that Postgres provides to do all the stuff that we do. And so sometimes there are some constraints that did exist previously that maybe have been fixed in the underlying Postgres implementation that we just haven't actually passed down. So one of those was, for instance, a really consistent way of folks using a database with a live application. If you are ingesting lots of data, depending on your data model, you might just simply always assume you're going to insert data. But if the data happens to be there, you want to update it. So we often call that an upsert. And in Postgres, that is done as a insert on conflict. So when that data actually exists, there's a conflict in what I'm trying to insert, do something. In this case, do an update. And so that was not possible up until recently in Timescale DB on what we call hyper table. So our time series partition table just wasn't. We were not taking advantage of some of the fixes that had happened in previous versions of Postgres to pass through that update based on a constraint name. So I think what was happening in Hasura is the when you set up the update in Hasura, the SQL that was generated for Postgres assumed that it would name the constraint because it knew what the constraint was, that said, hey, this is a unique constraint. So when you find a conflict, do it through the constraint. Well, that named constraint was not working appropriately in timescale DB, and that's been fixed in 2.8. So this issue goes back. I think I was trying to find this as we were setting up. I think the original posting of the issue was in 2019. And it's just, time series data models are interesting. And sometimes people have a data model because that's what their tooling provided. All right. So,
Yeah,
okay. So one of the
yeah,
reasons this is a problem for a lot of people that use frameworks to do their applications, whether it be to Django, whether it be a Node framework, what have you, is because lots of people use ORMs, object relational mappers. So they will make their objects in code. Hey, this is I have a IoT device that's sending me metrics every minute or every second or what have you. these are the metrics that it's sending. So that ORM creates the tables. And in almost all of them, there's just this kind of assumption that every table has to have an identified key, right? So primary key that then Hasura or anyone who's writing SQL statement can identify that exact row to do the update. One time series data that's not technically often necessary unless there's the chance that you have two readings for the exact same timestamp, sometimes down to the microsecond, depending on how much you've done with your data model. So I think that's why it's come up more often in a platform like Hasura is folks had their database because of their ORM. Every table, including the hyper table, had a primary key that was both time and usually a big int or something like that. And so these upserts would happen, and every so often they would actually do the update. But now we would have this problem with the named constraint. So that's all fixed. It now works. So it's been a longer standing issue, but one that we're happy to finally push through, along with a lot of updates over the last 6 months or so. We've done a lot leading up to 2023. Preparing to really become a great place within this ecosystem to have relational time series data.
Yeah, I think the upsert functionality is something that really hides a lot of power for a lot of different
Mm,
data models. Ones where you just maybe don't have a guarantee that the data set is complete, but you still want to at least capture what you have, and maybe some of that data comes in a little bit later. And I think that's one area that being able to use something like time series, supporting databases for upsert behavior really will actually open up a lot more powerful and potentially even just cleaner data modeling for a lot of people, because they're not having to sort of work around any kind of a bucket or a catch-all that then sort of drains into the time series DB, but can
right.
actually just say, no, we're gonna we're gonna just fire this off right away.
Yeah,
And
right here.
now T is a really great use case for it. So super exciting. Do we want to look at how that actually works, or you said you got some sample data we can actually have a look at? Yeah.
Yeah, so here's what I thought we would do if it's okay with you. I just want to, I'll give you a quick overview of what Timescale Cloud is, just to show you what our host environment looks like, get into a database we have. So, what I have is a database that is being updated as we speak with real time stock transactions. So, we can show you what that looks like under the covers and some of the features that people choose Timescale for in their applications, like they use through Hasura and other places to do graph queries on. And then we can look at that example query and what that update was, how it might perform currently on a sample table. Actually, I told you right before we started, I had to switch databases because I was trying to demo something that was not working in one that I was setting up. So we'll probably just take that actual ticket and give it a go, see if it works now.
Sounds great.
Awesome.
Gotta love live coding with databases.
Yeah.
And I mean, I
Oh, I guess.
and just well, while you
Yeah.
bring your screen up here, yeah,
Yeah.
I was going to say one of the things that we love is as developer advocates, like, and even just for anybody who's prototyping out a quick project or something, like having a ability to host something locally is great. Sometimes
Right.
the infrastructure part of that just takes too long. It's kind of like, I'm eventually going to host this anyways, like on a
Right.
provider. Why am I wrestling with Docker so much right now to get this stupid thing to run?
Yeah. No,
And
for
so
sure. I totally get
having
it.
one click thing sometimes is just like, okay, if I need to take this offline, I know there's a path for it. And so initially, like actually starting online development and then saying, okay, now we need to scale it out to the team and have the ability to work with like sort of a flow of data. We can actually offboard this off the cloud for local development as we spin up more people. But for the when you're the three people and a cup of coffee trying to hash out an idea, the early stages, I find more often than not, I actually start with the sassified layer because it's just like, I would like to just click this button and get my connection string and not actually worry about any of
Absolutely.
the other details and know that this is actually production ready to go. And I could go offline if I want to, but like, I don't want to.
Yeah.
I probably won't ever, but like right now, I don't want to. Yeah.
Yeah, and I think part of that conversation comes around, there really is a heavy emphasis across all platforms, and honestly, we're no different because we really believe in it. Is this idea just like Hasura has been built on, yes, I can run this thing locally to get a GraphQL interface into my data source and my website, but we believe in the cloud first mentality, right? We really want to see people be successful because I wasn't planning to do this, but I don't know. Let me just pull this up real quick. I think I even have it right here. I'll just do this. We did in the community. Yes, so we did the state of Postgres. We've done this a couple years now, and this is the state of Postgres survey that Timescale has provided. And I think one of the most interesting things here, I believe it's down under community ecosystem and tools. Okay, here we go. This is what happens in your live code, right? Might be up here, but we just started to see this real reality that more and more people are taking their services online. And for some reason, I'm not finding that. The PDF had a really good graph, which really showed that over the last 3 or 4 years, the differences between um, current, who's hosting something locally or in their own data center and who's hosting has changed just in the last 3 to 4 years. Something like 25 to 30% of more people happening, hosting their database environment in the cloud. And so the reality is, this is something we're all thinking about. We want to do well.
Well, and like your because it's I think in a big way, your host, and this is actually I think a big point for timescale. Your host does not often, or you hosting your database yourself does not usually differentiate your project. Like
Correct.
if you're
Yeah.
trying to create an app, your data model, your unique case on the data model, your integration layer, your ability to position this in a niche is what differentiates and what launches your product. But your ability to run this in your own, because now we can do Postgres and Kubernetes. Shout out to a show a few episodes ago. Like
Yeah.
your ability to do all that isn't always going to be the most critical thing that differentiates your code. If that's your thing, sure, go for it. But like when it comes to time scale, what does differentiate a little bit is when you do have a very specific flavor of a database or a very specific feature set that then the underlying infrastructure is able to say, hey, we're going to solve the unique elements that this version of Postgres or this database specifically require, and we'll solve that for everybody. And that's
Yeah.
where, like, okay, well, then Timescale has a business. And that's
Exactly.
differentiating. They can say we can do time series at scale for everybody, and that's great. And so I think that's a case where, as a product developer or a product thinker, in my case, is like I try to focus on things that differentiate what I'm trying to ship, not the things that I'm trying to actually say. Well, I did the whole stack, and it's running on this box under my desk, and like
Yeah.
that's yay me, but not actually going to make any difference when it comes to shipping the product. And usually it holds me up when I'm trying to get it to customers' hands faster.
Yeah, for sure. And I think the last point of that is exactly the reality of choosing a technology as well that you can go back and forth if necessary, right? Again, for us, we're using Postgres. This is not a unique, freshly written thing that is kind of unknown, maybe a little bit harder to host on my own if I needed or wanted to. There are instances, reasonable instances that people would say, "Hey, I started in the cloud, and maybe this is getting to be too. I don't need all of the stuff I'm paying for, and for now, I'm going to move it locally, or I found an alternative." And I think again, even with the licensing that Timescale provides, everyone has that opportunity on their own. Anybody can spin up an instance in any cloud provider, install Timescale DB to host their business, and keep going, right? So
Yeah.
that ability to go back and forth. I know you've talked to others, and I watched some of your other episodes. That becomes a real business use case. Knowing that you have that portability is just really essential to a successful business that knows how to work. And it might just be in the DevOps side of things, as you said a couple times. Maybe it's just how do I make my developers more productive? I don't need to have 15 databases in the cloud. I can do some of that locally. Great, move on and make that happen. So
Yep. Super cool
cool.
dashboard, by the way. Very clean.
Thanks. Yeah, we have a really top-notch design team at Timescale. It's been really fun to watch them do their work. So, this is actually about to undergo Timescale Cloud 2.0 refresh at some point in the future. I don't have specific details and timing, but you will start to see some really cool new
Is it
additions coming.
influenced by the aesthetic from state of time scale or
Oh,
state of
interesting. State of
Postgres?
Postgres. Yeah. No. So State of Postgres, we really chose over the last couple of years, very intentionally to actually make it. It kind of becomes almost an outlet for the design team each year. Like, hey,
Sure.
what is something new you'd love to do? And it's actually been really fun. So,
That's
I mean,
cool.
I
Yeah.
love this. My favorite was, I think it's work. I love this elephant sitting at the laptop. I just love it. So I'll take it all day.
Uh,
So yeah, I sorry I couldn't find the graph I was looking for. Again, this page, there's a lot on here. You
but
can
this
get the
is a
full PDF
resource worth
report.
checking out. Yeah, this is a
Absolutely.
resource for
Resource
everybody to
checking
come have a
out.
look.
We
Mhm.
give you the actual data dump. It's not anonymized so that anyone can look at all the data, do your own queries. I even give a example find a dashboard in there with a couple queries that people can look at. And we currently still have this database hosted on Timescale Cloud, so you can just get a read-only connection string and explore it yourself if you want. So this is Timescale Cloud, and again, you can get to this just about anywhere. You can look at Timescale. You know, we it's a like most people in the industry right now, it's a try for free for 30 days, no credit card required. You can just sign up with, I think, answering 3 questions in an email and a password, and you get logged in. And other things are coming soon, like federated logins through Google and elsewhere. So once you're in, Timescale Cloud looks like this, and it's again like many other services. You're creating what we call services, which are database instances. They are self-contained, and you can decide how much you need. You can scale both compute and storage separately, which again is unique depending on the provider you're currently using. And then any service that we are using, so this is one of the services I was preparing for today. Once the service is running, you have, you're not, we don't give super user at this point, but you do have a lot of other control over the settings of your environment. And anytime you do scaling or you change computer storage, we make sure that all the settings that are existing in Postgres, things like um, you know, uh, parallel processing of queries and so forth, that those settings make sense for the size of instance that you're running as you switch back and forth. We provide currently a little data explorer that kind of shows all of the tables and all the timescale features that you're using. Again, some of the updates coming in the future will be kind of more hands-on, a usable console interface for running queries and doing some of those things. That's in the works. And then features specific to timescale. So we want to make sure people are taking the most advantage they can of the timescale um, environment. So, for instance, in this general information, actually in this demo, I copied this over and undid compression. But one of the great features of timescale is we enable compression that can often save people 90 to 95% of their storage. And so we do a compression on time series data that is specific to data types. And we have some really unique ways of processing, and then it's all transparent to the user. So you just keep running SQL queries, and we will decompress the data as necessary in this columnar. So that means that now you can do columnar type queries on historical data that are really fast because they work on arrays and other kinds of compression. And you're only pulling off the columns that you're querying rather than, in Postgres, in a typical OLTP row-based database, you're always getting all the columns in most cases, unless you're just selecting from maybe a column from an index or something. And so it saves you processing, saves you page IOPS. So we just did recently at one of our newest benchmarks was, we hate to say against Postgres because we love Postgres, but just saying, hey, for time series data, when you are able to do something like compression, there's a lot. Not only are you saving 10x, 12x sometimes on your storage, but there are typical queries on historical data that can go, a month of historical data and millions of rows that can execute sometimes hundreds of times faster in Postgres because you're pulling one or two columns rather than the entire row for every single row you're querying. So there's a lot of good value there, and we try and point out whether you're using or not continuous aggregates and some other things. So we're going to look at all this in just a few minutes as we go. So Timescale Cloud, again, some basic stuff that you can do like auto scaling. So you can set up auto scaling so you never run out of space, and we'll take care of this as you get close to 85% of your disk space. which you can limit how big you want to get so that you don't get an unexpected bill, things of that nature. We do provide VPCs, so if you happen to be hosted in AWS, you can have a VPC right into each of your databases so that you have that direct connection and you don't have to worry about it. And then the last thing that we have rolled out over the last couple of months, which is huge, is just the ability to really, with a one or two clicks, add a replica. And so you can have multiple replicas, read-only replicas. So you have high availability. And again, like I said at the beginning of this the show, some of the team that's behind Timescale, they've been in this and they've been part of Postgres for a long time, including, as I said, some of the engineers behind a tool like Patroni, which is really one of the go-to high availability tools in Postgres. So a lot of stuff that we're working towards here, and just excited about those
Well, and that's
changes. And
huge
these
too,
are,
right? Because
yeah,
time series is very, very, relatively speaking, very few writers and a lot of readers,
yeah,
right? And
absolutely,
so this is a case where read replicas actually really could speed up the amount of performance and utility that your underlying database or your master database would actually be able to perform, because it's able to handle all the writes. And then because you have guarantees of order and stuff, that second delay to the read replica is not making a massive difference for streaming stock information, right? Like that's a whole bunch
absolutely.
of readers watching
Yep,
watching that dashboard, but they're not writing anything. It's just a couple of producers and just a lot of consumers. Yeah.
absolutely. It's a great point. And so, again, this is an area where we are really focusing on trying to provide the right environment for people to be really successful with relational time series data and manage as much of that as we can, and yet give you the control that you want when you need it. And so, there's a lot going on here. There's going to be a couple really cool announcements coming over the next couple months. Things like around storage. We are in the midst of some beta testing on block level archiving. And so allowing users within Timescale Cloud to say archive older data into S3 or object level storage like S3 and still do transparent querying on it. Right. So again, because we manage all those partitions, if you happen to do a query, we know the date range and we know the date range that every well, we call partitions chunks in Timescale. So if you go to our documentation, anytime you see the word chunk, to us that's a partition that most people would think of as a partition. Well, we know, hey, you're looking for data from 2 years ago. I know which chunks those are in because you have to partition at least on time, and I know that those happen to be archived in S3. I'm still going to go query it for you, and it will be part of your result set. It- just really awesome stuff like that that saves you space, allows you to still have access to your data, kind of like a warm access to your data when you need it. A lot of stuff coming here, and we're really excited about it.
Nice.
So what I did, this is one of those example databases that we have. So if you happen to go to our documentation, which I'll flip over here, we have a getting started set that, again, we're trying to keep updated as new features are added. You can do this on your own if you want. We provide a sample data set from a provider we work with called 12 Data, and so they provide us with daily real-time WebSocket connection to stock trade data. We query, I think, 100 or 200 stock symbols as the markets open every day, and those are being ingested right now into this database. So we give you access to basically the last month worth of that data. Usually ends up being maybe 8 or 10 million rows of data, so that you can use Timescale and start to see how some of these features work, things like compression, continuous aggregates that we're going to talk about. So that is what this server is doing. And then I think, hopefully, we have everything set up in Hasura over here. Um, and so what you'll see is that, again, I'm not I told you this in our kind of initial introduction. I have done a lot of the last 25 years. I've been in charge of a lot of app development at a couple companies, and I used to do a lot more of this, particularly front end work over top of APIs. But probably the last 8 or 9 years of my career have been mostly back end work and back end API development. So tools like Hasura are like, this is cool. I haven't had to worry about it all that much, but I know why we're using it and I know what the value
Yeah.
is.
Yeah.
So what this database looks like is we have a bunch of we have a couple tables And let me go to public here. We have a couple tables that I've already tracked in Hasura, right? So the main one is the stocks real time. So this is happening as we are talking. If I were to order this by, there we go, by time, you'll see that we are, nope, let me go descending. Oop, meant descending up here. Thank you. So you'll see that this data is coming in.
It'll load you.
It's come. So this, the free Hasura one is on the West Coast, and this is, of course, on the East Coast. So we're having a good time going across and figuring that out.
I think it's not loading. Something blew up there.
Okay.
Maybe try refreshing.
I will try and refresh. Come on. Maybe I'm pushing my rural internet connection here too hard. There we go. It's still not descending though. We can run this in the other if need be, and I will maybe just show you.
We can just run it inside the API Explorer. Be escape out of the UI land and go to the API tab up there at the top.
Yeah, sounds good.
Yeah.
So this is stocks real time limit, and I think I need to order
Order
by
by, yeah.
time, and we'll do descending. All right, so if I do that, you'll see, here we go. So we are currently talking on the 11th of December. Oh my goodness, 11th of October.
October. Yep.
And on my clock, it is 1:44, and so I'm a minus 4 right now. So you'll see that we have data from just a minute or two ago coming in on these symbols. So we only tracked a
Yep.
few symbols. We might not be getting absolutely everything as we go. All right. So
Now
that's what's
now
happening.
that's a
Yeah,
that's
go
a
for it.
that's a default Postgres table, right?
So that good question. That is actually a hyper table. And so
Okay.
what we did is, now zoom this up just one or two more here. So essentially, and this is in that tutorial, we simply create the stocks real time table. In this case, it has 4 columns, and these are just the instances we're getting over time. And then we create a hyper table out of it. So that's all you have to do to create a hyper table in TimeScale. And that allows you to then at that moment, take care of all the partitioning, and you never have to manage anything about partitioning from that day forward. So Postgres does now have native partitioning. That was added in Postgres 10 and improved in Postgres 11. Postgres 15 is going to be released in the next couple of days. And there's a lot of power behind native partitioning as well. One of the things that it does not do, however, is it doesn't maintain partitions automatically. So you still have to always have the partitions ready and available to receive data. With TimeScale, you simply run this one command and you're done. And regardless of what data comes in, it can be 18 years in the future or 20 years in the past, and we'll create the partition for you, insert the data, and move on. And you never have to think about it.
Now,
And then you just query it.
can you receive data out of order too? So could I, in theory,
Absolutely.
my ops team is backloading in the archives of transactions, and so we have 10-year-old data being streamed at the same time we have at the moment data, and that's all put into the correct partitions real time.
Real
Like this
time.
partition is never going to be touched. So it's
Yep.
way down in the pagination. Okay, very interesting. That's a
Yeah.
lot of power right there.
It is a lot of power. I mean, again, every situation is a little bit different. If every single row is spanning, a partition years apart, it's going to be slower, but it's still just going to happen. It's not going to be,
Yeah. Yeah, yeah,
it's
yeah,
not
yeah,
going to
yeah, yeah,
stop you from
yeah.
doing it. Yeah,
Does
that's a really consistent scenario. I pull this off often. So the company I came to Timescale for, we were they still are a large IoT predictive maintenance company in the US. And so we had these devices, the vibration devices that we would magnet onto big equipment like paper mills, fracking for gas and stuff like that. And same deal. They were particularly in fracking, they'd be in the middle of, for an international audience, you may or may not know, but North Dakota is like the barren wasteland of America. And
that's
you
the
don't get,
American version of Timbuktu. Yeah.
there you go. It's the American version of Timbuktu. And so sometimes the devices, the computer that would store the data would get disconnected for a week, and then the trucks would drive into range, and we'd get a week of data, or sometimes a month of data, that's late. And you're right, there's some time series databases that actually don't know how to handle that, or don't know how to handle it well. And so that's never been an issue with timescale. There's a couple nuances there, really only around compression. When you compress data, you can insert new data, but you can't modify compressed data because
Hmm.
we've literally changed it from a row into columnar data, and compressed it. Not just that, if it was columnar, that might be one thing, but we've actually then also compressed it,
Change its type.
which
Yeah.
it just changes it. And so we would have to decompress it and update it and so forth.
Yeah.
Uh,
Decompress everything, compare, look for
yeah,
an update and then, yeah. So, yeah, yeah,
yeah.
yeah. That's
And
helpful.
so we've ways around that. What if someone had that situation, and in fact, this is what the previous company that I was with did. We'd say, hey, you load that into a staging table. It's old. Load it into a table. You have a process at night. We will help you. We have some scripts that we can help you with. Identify the partitions that will need to be updated, and we'll help you work through that backlog to decompress, insert, recompress, and so forth. So you still get all the benefit. It just might be a little bit late.
Now, I just want to do a quick side trip. So, vibration sensors will
Yeah.
basically detect for abnormalities in vibration behavior. So, kind of telling if a
Yeah.
machine is starting to break down because it's shaking harder, or
Exactly. Well, two things. Most of the benefit in most industrial machinery is all around bearings, right? Almost everything, every machine you can think of has a bearing doing something, some kind of rotational movement. Robots on a manufacturing arm. There's a lot of automobile companies that were their customers. I don't think I can specifically name them.
but ones
But
that are
we
using a
can.
lot of robotics. Yeah.
I'm just saying, whoever might be putting cars together for robotics in America. So
Yeah.
anyway, and so yeah, we would basically every time the robot moves, we know it's about to move. We would track the vibration of the bearing, and then it turns out that bearing research has been like 120-year uh, like niche, and there are charts of every single type of bearing, how many balls are inside of the ball bearing, what kind, how big, and the frequencies they produce for different kinds of failures. And so we could hear them based on the vibration. We could say, hey, that truck at your frac ground is probably going to die in the next 5 or 6 hours. It would behoove you to stop it now, get a new truck in there, and fix it, and saves a ton of money. So yeah.
And fun fact, I think Norwegian ball bearings are supposed to be some of the creme de la creme. And I only know that because I watch a lot of YouTube blacksmithing videos, and it's one of the
Oh,
things that they
nice.
love to get their hands on is is,
Oh, that's
is
awesome.
old ball bearings and housings from one of the Nordics. I believe it
Okay.
is Norwegian ball bearings. But anyways,
Yeah.
um,
No, that's
I'm curious.
wonderful.
Do hypertables support subscriptions in Hasura? Have you checked that?
I so They do. I have not personally done it. We did a little example a year or so ago for a different reason. I think actually maybe one of your like during the pandemic, everyone was doing kind of webinar series and so forth. I think we did something back then,
Yeah,
and it was
we could
based
check it
on.
if you go back to
Yeah.
the
So yeah,
API
I'm
store.
happy to.
Yeah,
Sure, sure.
because all it is just adding the word subscription instead of query, and right where you have the actual API there. So if you go instead of writing query there at the beginning, if you just go right into the editor,
Right
you
here.
see where you have over in the window to the right. Yeah, just change that word query to
Oh,
subscription,
okay.
and go ahead and run that. And so with that, we now have real time data from the time series streaming in. So
Oh,
whenever there would be a
okay.
new transaction, we would actually get that brought up.
Give me 1 second. We have a
Yep.
visitor who forgot that I was recording.
Yeah. No, I mean like on air kind of thing would be amazing.
Yeah.
So
No, you're totally
um,
right.
yeah. But this is fantastic. So I mean,
Yeah.
when we look at this real time data, right? So we have subscription data now with time series, natural fit here. I'm almost wondering if this actually would support, and this is something we neither of us had checked, if these hypertables support the new streaming subscription paradigms that we have. And so
Yeah.
To do that, all you would need to do is next to the after the word time would probably be
Right
just
here.
to underscore underneath the root field there. So the stocks real time root field you've
Okay.
got queried. After the word time, it would be probably underscore stream if it exists. Look at that. And
All
so now we have
right.
to change the input because the arguments are a little bit different. And we can see there on the helper with the explorer on the left side, we can see kind of what
Yeah.
it's looking for. So we can put in a batch size, put in something like maybe 10 or something is fine.
Okay.
And then we need a cursor that will be time based in our case. So if we were to put in a time value of like maybe an hour ago or something, um, we can to maybe just grab one of those most recent time values you have and display there, and we'll just subtract an hour off of one of them.
Can do.
It looks like it might need to be quoted in strings, I would guess, but it's not. Maybe not. That might be okay. And we'll need to just remove the limit and order by fields,
I was doing it
which
automatically for us. Get rid of that.
yeah, we had just a little.
All
I think we
right.
need to put I think we need to put a quote on the end of that. I think of the time
Oh, I
value.
thought, there we go.
And ordering, we probably want to put an ordering on that, so we have a
Okay.
we have that properly correct. But from there, so yeah, as you can see, it's streaming the
Yeah,
data
it's
now because
streaming right away.
it's in reverse order, but it's sending us pages of data. And then when new events would occur, which is really cool about this, especially if you're talking about time
Yeah.
series data, instead of whereas live queries, though the subscriptions without the stream appended on
Okay.
there is sending us the page size um, every time with the WebSocket request. So it's giving us
Oh,
like
gotcha.
maybe we have 1,000 records. It's sending us a payload of 1,000 records every single time, and
Okay.
that's just a lot of data down the wire. Whereas
Right,
streams,
right.
we could say, hey, we're talking about millisecond changes for like a big fire hose of stock exchange data. You don't want to be getting 1,000 of the most recent records every time. You want to be just
For
getting
sure.
maybe the one or two and then kind of push those into your interface and really clean up how much memory your machine's having to process with this data and finding the subset of change and everything else. So this streaming
That's awesome.
subscriptions with timescale data becomes an extremely powerful primitive to build with, because now you have the best of these um, you know sharded tables, basically under the hood, partition tables that are going to scale infinitely, and you're going to get then all this real-time data, which is really a powerful concept here.
Yeah, for sure. Yeah, so here's AMD, which we know trades a lot and things are coming through.
I
Well, that's a
think
good
that
segue,
yeah.
Jesse.
Mhm. Yeah,
Oh, go
good.
ahead.
I was just wondering about our timestamps. I wonder if it's if we would reverse it with the order by, if we just were to switch from ordering to. I think I think we have a goof here. I think we change our paradigms from ascending and descending when it comes to streaming. um, if we change this to descending, we should just get the most recent 10, and we can make that batch size even smaller. Um, if we were to change the order to ascending, maybe
Okay.
just see what happens. Does this
Interesting.
does this
Yeah.
timestamp look
So,
more correct, or
good question. I'm not
change
sure how this.
the batch size to 2? So we, in theory,
Yeah,
might get, and then
I'm not
we'll
sure how
change
this
the.
timestamp on the stream is
Yeah, maybe
sets
make
up on a map
a bit
fully.
more recurrent. Yeah. So we have the first two there, and it's
Okay, so you're saying the initial value um, of the
the
cursor.
cursor. Yeah, the cursor has to be related to what we're trying to compare.
Okay.
And then the order, we should get the most recent top two. but it's the comparison that we're having, right? So it's slicing off. So if we have an hour to go, it's still going to try to give us the whole hour of data, as
Right, right,
opposed to
right.
something like now. Um, I think they might have fixed this bug. We support this with Postgres in general. If you were to delete all the content inside of the date selector there, and do
Right here.
single quote, yeah, do single quote now function, so the Postgres function for now, and then
Mhm.
run that with. We could try that. Actually, no. Let's try and see if it actually works. But go ahead and do the stop and start again and make them plain.
That looks more like what I would expect.
Okay, so now we're getting
So we're
it
probably
realistic
yeah, we're
data.
getting
Yeah,
yep,
yeah. And now we're getting real time
10,
batches of two records, because there's just
yep,
so much trading action happening
yep,
that we're constantly getting results. But yeah, that's kind of cool, right? Like we're
cool.
getting
Yeah,
real
that's
time
awesome.
pushes of data. Yeah.
I like this. Yeah, so, this is actually probably a good segue to the other thing I was gonna show about timescale, which really is one of the key features that most people I know that come to timescale to use it are coming for, and that's, besides compression, which is huge, both in speed and the ability to query data, is what we call continuous aggregates. And so, again, I've watched a couple of your recent shows. I know that anyone who says that they are Postgres compatible, whether they are actually built on Postgres, the actual code base in some way, or they're Postgres compatible. You and Craig had a great back and
I was
forth
gonna
about
say I know
this.
which episode you watched.
Well, but it's true, and I think that's the reality. It speaks to two things, right? One is it speaks to the value that Postgres is bringing and that people are finding with this code base. It really has become the standard SQL. When people say, is it SQL compatible? Whether they understand it or not, they're saying, is it Postgres compatible? Does the SQL work compared to Postgres? Because that's what people are learning and knowing. And so materialized views is a great feature. So again, I go back to this, to my old company and a couple companies before that were similar. I used to do energy data, right? So it'd be things like electricity usage on 15-minute intervals or even monthly utility bills. And of course, everyone wants to be able to compare my total spend or my total usage over specific buckets of time. Well, if I have 10 years of data and I try to query, in this case, 30-minute buckets or intervals. So, what was the usage for this 30 minutes and the next 30 minutes and the next 30 minutes? As the data gets bigger, it gets slower and harder. The query engine has to work a lot harder to make that happen. And most of the time, that result doesn't change once the data's in, right? Aside from maybe an update, but usually, most applications can say, hey, after X period of time, if it's a utility bill, maybe that's after 3 or 4 months. I'll give you 3 or 4 months to update that utility bill usage and cost. But after that, it's a little bit more work to update it. If it's real time vibration data, maybe we say, hey, you have a week. And after a week, we're not going to let you change that data because we're going to pre aggregate those results that you query all the time for all of those reports. And 99.999% of the results never change because the data behind it never changes. And so, before I had something like materialized views, we would go through all of our own antics and gymnastics to make that work. We would track every device and the last time it updated and last time there was this. And then we would have a process that would kick off every hour and it would pre-aggregate it, save it in another table, and we'd have 5 tables for different levels. And everyone I know does that. When it comes to this kind of data, every single application I've known of has to do something like that. And one of the reasons is even materialized views have one problem. As great as they are static. So when I run a query as a materialized view in Postgres, it takes all of that data, whatever the query is, whether there's a where clause on it or not, and it literally saves it to essentially a table. And now you have a view that you can query just like a table. You can create indexes on. It's fast and everyone's happy. The problem is we have stock data coming in right now. 10 minutes from now, the last 10 minutes of data is not part of that view. It has to be refreshed. And in Postgres, the only way to do that is to literally run the entire query again, even though 99.999% of it has not changed, so that I can get the last 10 minutes. But as soon as the query's done, I'm already out of date. And so we decided to come up with continuous aggregates that take care of that problem. The cool thing about continuous aggregates is it uses the same underlying interface as materialized views with a couple of parameters that you can pass in, like one I'll show you here in a second. And then we provide the runtime engine underneath to track all of the data updates. And then we're really smart about it. We don't just update all of the data all the time. We say, hey, where's the new data? And if you happened to update something in the past, we say, oh, well, we'll just update that one bucket. Why update everything? That's the only one that had a change. So let's just update that one bucket in the continuous aggregate so that the processing is fast and you can query it. So what I've done, and the reason I thought this was a good segue is
Yeah.
in Hasura, one of the if I go to the data explorer here, I already had two continuous aggregates. So one is a 1 minute candle aggregate, and one is a 5 minute candle aggregate. So in stock data, we talk about candles. That is, for a given period of time, the high price of that time period, the low price, the open price of that. So at 9 o'clock, it opened at $10, but the high of that 5 minute chunk was maybe $10.50 or something like that. And so we come up with it's called open, low, high, close. And so I have two of those. One is the 5 minute candle, and you'll see that it's in buckets of. I almost always have my pointer going, but I didn't for this moment. It's almost always in. There we go. So it's 5 minute buckets. Might be a little bit hard to see here, but depending on the symbol, we start at 1300, then 1305, then 1310, and 1320. So we've pre-aggregated those buckets for you, and then we append the most recent data when you do that query as a real-time query. So 90+% of the data is already aggregated. You don't have to do the work. And we'll just tack on the most recent data that's come in since the last time we refreshed that data. And so it makes things super fast and easy to use. And these are views. And so in the API Explorer, I should be able to use those views. Here's my 1 minute candle, and I can select, and I've called them something different, but I'll just get all of the data. And I'll do an order by bucket. I just always call it a bucket, but I'll get the most recent bucket. And maybe we'll just do the last 100. And I have to get rid of one of these, don't I? This would always. I guess I don't have to. So that's the one thing I
You
didn't.
can, yeah, you shouldn't need to. Go ahead and hover over it. It'll tell you what it's complaining about at the moment if you hover over the red squiggly. Um,
Okay, one
so
top
in
level
this
field.
case, for subscriptions, it's only going to want one top level field. So if you go ahead and delete that top level there, actually, you can leave the subscription because it'll actually still
Okay.
work in this case. Which case, it's giving the consumer of the GraphQL the real time query that you're getting from the real time API from TimeScale. Because if you were just
Okay.
getting a single query, you could query again and again and again, but the logic you'd still need to somehow indicate from to the client some sort of way of fetching that data. So if we now, it could also be that maybe the views don't work with the subscription. We could try a query, see if it works first of all without the subscription. So we can try a query there instead and see if that works. Or it could be that our data's got a. Let's have a look.
So I will
Or is
admit
your offset
I.
too big? Is the offset too big? Maybe try a smaller
Oh,
offset.
offset. Oh my goodness. I thought I was doing limit.
So I was gonna say the table looked a little bit smaller when I saw it.
Yeah, my bad. There we go.
There we go.
Thank you for catching that.
And let's
So
try the
this is
subscription
taking.
instead of query too. Yeah.
Yeah, sure.
Because then that'll change the data. So every time this data changes from the subscription side, I don't have to do anything else. I can put that inside of my chart, and if this aggregate changes at all, I get the current data
Okay.
from whatever time scale, which is a real time query in this case, and
Yeah,
it's saying we've changed it. We're just pumping any current changes to the client. Yeah.
sounds great. Yeah, what I wanted to make sure. So what I've shown here is that we have currently a 1 minute aggregate, that's always being updated, a 5-minute aggregate. So a lot of UIs will allow you the ability to change between a couple different aggregate levels when it comes to stock or financial data. So you can do candlestick charts over time. And so in timescale, you can have multiple continuous aggregates over the same data. You can set how they refresh over time so that you're only getting what you actually need to get, and working through it that way. Um, so that is the power of doing something like continuous aggregates. What I was going to show, I think, what I realized is I got this all set up, and I think I intended. Uh, I thought I got rid. So here, we'll look at this really quickly. We have something called timescale DB information and continuous aggregates. And let's see what we have right now. I think I got right. Yeah, so we do have the 1 minute. And so that probably worked better on the 1 minute API. Did I just get rid of it? I did. And so you're
Get rid
saying
of
we do a
what? The query or what?
subscription.
There's a history you can browse as well, and
Oh, there you go.
yeah.
We'll do that. We'll say 1 minute.
That one has the offset bug
Oh, I
still in the
still have the
query.
offset. Thank you, man. I limit.
That's the problem when you work with history from a flawed history.
I know, right? Okay. So there's a chance I was trying to set this up. I thought, you know what? I got everything ready. There we go. So there's my 1 minute. And you can kind of see that in here that this one is 1810. So again, we're at UTC time. And so currently it is 11 after for me. And our buckets start at the beginning. So this is actually the 10th
They're
minute of the
rounded.
of the
Mm.
hour. They're rounded, right? And so with a subscription, you're
Or
saying we
clamped.
should
It's
see that
clamped, not rounded.
change. Oh,
Yeah.
so I need to do this as a
Yeah.
subscription,
Mhm.
and in
The
theory, we would then see
clamping
that
is the
go.
term, right?
Yeah, I think you're right. So there we now have 11. So we're into the 11th hour, and what should happen is, you know, maybe I'll let this sit here for a minute. If we talk enough, it would update into the 12th hour because behind the scenes, we're going to update this aggregate for you as the data. So data's coming in right now, and then the engine's going to run. It will actually update the view, and I would assume then we would see that view
Yeah.
trigger.
So we when's the time window? It's the 11th hour, and so you're expecting us to roll into the 12th hour here, yeah?
The 12th minute at some point here. So this
The
is the
12th
one
minute,
minute
yeah.
candle, and so it's just turned over 12. The way it works is there's a schedule that's run, and you, as the user, get to set that up how frequently you want that to be updated.
Sure.
And so
So
probably in the next,
we'll give
I,
it a minute here, yeah.
I would hope in the next minute or two, we'd see that roll over.
And
Yeah.
one of the
So
things we could do with this too, and if you're using the Hasura Cloud version, is let's say you are comfortable with a little bit more of a delay too. You could also then, from just the query side, you could put a simple cache on this as well. So while you want the real time data, you could just save yourself some of the speed performances by just throwing a cache directive on it and be able to get that data as well, just
yeah,
like a
for sure.
small buffer for performance wins.
Yeah.
But so let's see if we get the rollover here. It looks
So I
like
expect it to be right about now. I'm sure that I have it. So I'm not
we
sure.
can yeah, we can compare it with
You're
we could
saying
also
what was
just a
the interesting part?
stream,
So
yeah, but that would it should still work because what we're getting is the
gotcha.
inputs are input arguments are
Yeah, the
different
inputs are
for a
totally different.
stream,
Yep.
yeah.
Yeah, I remember
Let's
that.
go ahead and try and running the query again, see if we get the update. So it's still got the old, if
This
you scroll down, we could see if we need to maybe make it be ascending versus descending, but you could scroll
Yeah, so
down,
this
see if the
could be
data is older.
me. You know what? This is exactly what happened. I think this is probably my fault. As I said, I had gotten this all set up, and then
Yeah.
I unset some things on the 1 minute continuous aggregate, thinking I would. So if you notice down here, I was getting ready to set up the refresh. So that's probably what's happened is I don't have this thing refreshing fully, and so that's on me. Um, but that's the power of doing continuous aggregates, and really solves a problem that almost every single person I know, every application I know that has time series data, whether it's specifically you would think of it as like analytical aggregate reporting data or not, everyone ends up doing aggregate reporting on their time series data, and they
Yeah, well,
run
look how
into this
expensive
problem.
that is. If you run it inside
Yeah.
of like, I was who did I have on as a guest who told me about a it was internal employees during the first BigQuery talk we did,
Oh,
talking
interesting.
about a analytical query that was for a dashboard view of some kind of performance, and he would kind of sit there and he'd refresh this thing. But the way that the BigQuery data can work if it's not tuned or properly safeguarded, actually had it was like running a $50 bill or something every time you hit query. And
Yeah.
so when you're talking about running, a real time aggregate that is intelligently updating the materialized aggregation, if you will, as opposed to completely going back through the whole database again, you can see how that is a massive amount of performance win that you would not have to be having to worry about, like the infrastructure for.
Yeah, so I'm just gonna run this. I mean, this is the point that you're exactly making. This is this query, and in Postgres work, and Craig probably talked about this. Everyone I know ends up talking about it. We have things called pages. So that's like the actual pages on disk that are read to satisfy this query. So I just ran that query on the data for the last 6 hours, and it had to read almost 50,000 pages off disk, which I'm not going to be quick enough at 8K pages, how much that is, but it's hundreds of megabytes of data at least that it had to get just to do this. If I do that exact same query through, I'll just do select star from 30-minute candle, say where, and instead of time, it's bucket. Do the exact same thing. All right, Ryan, just copy it. It's a whole lot easier. Uh, and you do this, and you'll see number one, it's instantaneous. And we had to read 1,800 pages, right? Because the data doesn't change. And so you just saved yourself whatever that is. That's 30x work that you just saved by using this view. And now you put that on top of your graph, your graph interface, and your app becomes instantly faster and your server becomes happier. Like there's so much about this that's
And
completely
less
unreal.
expensive. Like this
Less
is not
expensive.
just faster,
Absolutely.
this is less expensive. I mean, the at the end of the day, like there are cases where you may need to work within the constraints of what pure Postgres provides, and that's like a valid use
Absolutely.
case. If you're able to go for a vendor that has solved this problem specifically, and is providing even hosting for these specific fixes, like then I mean, this is how companies exist, right? Like, right, yay,
Is
yay
how
free
companies
markets, like where
exist.
you have
Yep.
the ability to say we're going to solve this pain point, and if
Yep.
that is a pain point you run across on a regular basis, that's fantastic. It's a great way to work.
For sure. Yeah. So that's I'd say that's probably the main highlights of kind of where timescale can really solve a lot of problems that folks are having,
I mean,
and the way
time
use.
series upserts with real time aggregates, all of it with streaming subscriptions on top. I would say, like, and the quote, I don't even know who I'm quoting when I say this, but the "Are you not entertained?" Like, is that
Yeah.
not what you wanted to see? Like,
Yeah,
that's
exactly.
such a powerful toolkit to work with, to be able to say, if you're working with real time data where you need to also have aggregates on it, and you're also not needing to stream this to clients that you don't want to be sending a megabyte of data every half second or whatever that WebSockets are tuned to, like
Yeah.
this combo, and that we got for free, by the way. Like,
Yeah.
we all we did was, I mean, you had to write the materialized view for the aggregate you wanted, but then that gets exposed instantly inside of Hasura once you track it. So, well, I'm going to track this now, and now I have all of this data, real time aggregates plus the streaming subscriptions. Like, that's
Yeah.
really, really, really powerful. I can just
It is.
imagine telemetry people, like, this is a great thing for telematics, right? Like that's the tracking of
Yep,
vehicles or things
absolutely.
through space. Like that's incredible stuff there.
That's
And if
machine
you add
learning is based
relational
on all of
data,
this,
right?
right?
Add
Yep.
relational data, you can do real time geo tracking as some post just on it.
Yeah.
Good stuff.
It's very true. That really gets to the heart of maybe if I'd part with one thing, it's that gets to the heart of why Timescale was created, right? The company, the group that got together to do this initially, and why we continue to exist and believe in this, in where we're headed and what we're providing is, again, I hate to keep going back, but it's like every company that I've been a part of, if SQL couldn't, if a relational database couldn't handle this, most companies have at least two, if not more than two databases to handle all this. They'll do time series in one database. Maybe they have different databases for different time series, a historian and a Cassandra cluster, and one of the many AWS services, DynamoDB or something. And then they have the relational data, and the problem is every single time I had, so again, in this company, we employed big staff of certified vibration analysts, right? So they would work with their clients. They'd say, hey, I'm seeing this anomaly. Can you run a quick report of X? And I'm like, well, no, I can't do that because I can get you the relational side and I can find the nodes that you want. But now I have to go figure out how to get all this data out of this completely disconnected time series database. And then I still have to do the work to munge it somewhere to get you the thing that you want. And so that's exactly what happened with the company that started the folks that started Timescale. They were working on a time series application. Like, you got to be kidding me. We got to do like all this stuff just to get a report we want. What if we could just write a SQL query? And so that's where we are. And it's
Yeah.
been awesome. It's been fun to be part of and see what they're
My
doing.
mind is just is buzzing with a possibility going back to the first episode in this data series we've been doing about adding then PGML on top of that and what you could do with predictive
Mm.
analytics with time series data.
Yeah, I watched that one.
Then you have a
That was a great
startup,
episode.
so yeah.
Yeah. No,
But
totally true.
I have what?
I
Yeah,
meant
good.
to go ahead. You talk, and I'm going to find something here.
Well, I was going to say I do have one question about timescale that I haven't been able to find the answer to just yet, though, and that is why
Yeah.
the tiger?
So the one of the founders of the company, and where a number of people kind of met up, uh, is a professor at Princeton. And so the I believe it's funny. I've asked that a long time ago, but I can't remember. So somehow Timescale was actually a potential client. Said we had a different name and came across with Timescale. Was like, oh, we really love how that is. And then whoever we were working with the clock, and Princeton, their mascot is a tiger, I believe, if you look that up. So
Could be.
now,
I'm not Ivy
don't quote
League.
me in that. And if I email you after the fact and ask you to cut it, but yeah, it's been a while. It's been so long since I've
That's
asked. Our
funny.
cute little this guy over here, you can kind of see right here. This is Eon. Eon as in a measure of time, and
Time, yeah,
so you'll
sure.
see Eon over the place. We love him.
Yeah.
They does a great job. So yeah. The last thing I was going to just mention, and I think this is the other thing that honestly sometimes I forget because there's still so many people that are doing those basic operations in their data, in their time series data, that it's easy for me to get just repeat over and over again. Hypertables, continuous aggregates, compression, right? Because they are so transformative into how you work with your data. Even things like user defined, what we call user defined actions. We in Timescale 2 and beyond, we provided the ability for users now in Postgres to schedule their own uh, functions and store procedures. So up until then, you had to have another extension like PG cron or something like that. So we said, hey, we're already doing this. Why don't we just give users access to use the same scheduling engine? So all those kinds of features exist. But one of the other things that's really near and dear to us is making analyzing the data as awesome as possible, because we believe in time series data. We know there's so many things that we can do, and so that's one of the other things that, again, if you're part of Timescale Cloud, or you can actually, install it on your own. We have a separate extension called Timescale Toolkit, which is a set of now over 100 functions that are unique to time series data analysis. Things like approximate distinct counts, and you have huge amounts of data, knowing how to do We support two different, like hyperlog log is one of them. Things like gap filling is everyone needs to say, I'm selecting those 1 minute intervals. But what happens if one of those devices stopped reporting for 5 minutes? But I still need to show that empty space in my graph. So we provide a way to do gap filling. So you still get the timestamps, but you can see that the data isn't there. Time weighted averages, um, counter aggregation is huge. So this is where, again, you have a lot of things where counters count up and they have rollover. We take care of all of those kinds of measurements and aggregations within these functions for you, and they just come as part of timescale. The one that's the only reason I remember to even talk about it, and we might not, it's so new that I'll be honest, we might not have it in here yet because we just released it in beta. I'm going to go down here to the API reference and see, is actually an open high, low close aggregate. So the coolest thing about these functions, if you noticed when I was back here, I said, hey, we have three different continuous aggregates. I have one for 1 minute, I have one for 5 minute, and I have one for 30 minutes. And sometimes you can re-aggregate them up, but sometimes it doesn't make sense, like an average of averages. But what we've done with these hyperfunctions is we've created an efficient way of storing the aggregate data. So here's financial analysis. We have an open, high, low, close aggregate. So for every bucket, if you were to store, for instance, a 1 minute bucket, we now give you a way to correctly roll that one thing up into higher level aggregates. So we're, again, providing tools for users to be efficient. What that means is this: rather than having three continuous aggregates, I can create one, and then at runtime, at query, I can say, hey, take that 1 minute and turn it into 30 minutes and make sure, and we'll do the right thing. We won't give you, the incorrect data based on, we'll make sure that we find the right high, the close, things like averages, and that nature. So we're always looking forward to the future, how we can make this easier for everybody.
That's a tool. That's a toolkit.
It's exciting. It's super
If
fun.
you're working with time series, you need to have a look at TimeScale because they're really pushing the envelope forward. And there's a lot to be said for companies that are, companies that exist around open tooling like this, because this is something
For
that
sure.
allows them to push the envelope to support engineers to explore the what if questions. And it's not all evil greedy corporations. Sometimes people
It's not.
actually do deliver value
No.
when they work on this stuff.
Yeah, I came to I came into the Postgres community from a different database community, SQL Server. And I'd say for the last 2.5, 3 years, maybe the last 4 years, it has been this learning opportunity to understand that there is a huge worldwide community around this database. And there's a lot of strong opinions, and there's some real value that's created by having those strong opinions. If you go look at that, the state of Postgres, there's a lot of folks worldwide who kind of think, hey, this is still developed in an antiquated way, right? They have these mailing lists, and you got to send patches through email, and yeah, there's consistent discussion month after month and year after year over having that right balance so that you continue to maintain a really high quality open source product, which is really, really hard to do, and provide something that serves a growing user base. Postgres is the fastest growing database, relational database in the world. It just is. There's no argument to it. So there's a lot going on. It's fun. I encourage people to get to the conferences that are in their regions, both Europe and America and so forth. There's a lot more user groups starting up. Get involved. There's so much that people can learn and can contribute. So
And just to put a little Hasura bow on it too, like whereas becoming a database person would have typically meant you had to go into this whole ecosystem of, okay, well, then I have to become a SQL person, and I'm really afraid that I'm going to write this thing wrong. I'm going to either destroy my
yeah,
database or I'm going to expose all my customer data. Using tools like Hasura will give you those sort of guide rails where you can explore Postgres and then be able to start to actually look at like helpful tooling to, how do I interact with this database in a healthy way? How do I put sensible protections in place? And so, especially if you're new to databases or you're looking into something like Postgres, and Hasura supports more than just Postgres these days too, but like
oh for sure.
is a really great way to sort of get into databases, is having some sort of safety around that. And Yeah,
Yeah,
definitely look into the Postgres worlds one we've been excited about for quite a while. And
that's
Ryan,
great.
any last thoughts from your side? Anything you want to leave the
Want
people
to do?
with?
Oh, I just want to do two really quick things. We didn't
Yeah.
actually get to this final conflict, but the reality is this is in timescale 2.8 and ahead, and so this is actually in the Hasura um, GitHub issue. I don't know that at some point we did track. I guess it's this one here. I linked back to it. So any users that have tried timescale before with Hasura, again, timescale 2.8 and above, this is fixed as far as we've been able to reproduce, and really thankful for just how many people contributed feedback to this to make this possible. So that's good. And again, you and I have talked a little bit. Community is big, and I did want to give not a plug for me, but it is a plug for the Postgres community. I've been able to had the fortune of giving a couple of talks at some of the Postgres conferences recently. One of the ideas we had was how to open up the Postgres community a little bit more. One idea that I took from another community was called, it's basically a monthly blogging event. So we had our first one this last week. So the first Friday of every month, we have people trying to host. We're calling it PG SQL Friday. And just another way to start to figure out who within the Postgres community is doing the work, what we're able to provide, how to get involved. Anyone that watches this that's a blogger that uses Postgres, we'd love to have you contribute. Just you can go to my blog, you can go other places and find kind of what to look for, and you'll see something every month. Someone's going to be hosting this and say, "Hey, contribute something, and let's build this community a little bit bigger."
Fantastic. Fantastic. Also
Awesome.
love that name of that domain, software and booze.
Had to take advantage of it somehow,
you
man.
got you gotta lean into it, shaking not stirring.
Gotta own
Very
it.
fun.
Just it's all good. Yeah. My wife
Very
always wanted
good.
to know, like, can we just pronounce it? No, it's just what it is, honey.
It's
Sorry.
what it is. It's what it is.
All right,
All right.
Jesse, it's been
Well,
a
we're going
pleasure.
to wrap the show with that for today. And again, fantastic. Thanks for coming out, Ryan, and showing us Timescale. And one that I'm actually going to have a look at a lot more too, because I think there's a lot of cases where I'm getting into sort of sensor stuff and Raspberry Pi and all that kind of thing. And
Yeah.
a lot of that stuff's time series. And
It is,
man,
yeah.
fantastic.
Check out our blog. There's one of the new developer advocates you'll probably run into. He's in Germany. He's up in Berlin, so not as close to you, but he's been starting to put out some how tos on photovoltaic. He's doing stuff on his house and how to track that in timescale
Oh,
and using
fantastic.
Raspberry Pis, things like that. So yeah,
Well,
lots of
definitely will
fun
check
stuff.
that out for sure.
Awesome.
All right, that's going to wrap it for this show. Thanks again for Ryan and for the Timescale folk for giving us the time. And we will see you all at the next show. Have a great rest of your day, everybody.
Take care.